Section 6.4 is on nth roots. The nth root of a number is the inverse of raising the number to the nth power. Remember, n can stand for any number. So we can have a fourth root, a fifth root, a sixth root of a number, which is just the inverse of raising that number to the fourth, fifth, or sixth power. So, for example, since 4 to the third is 64, that's 4 times 4 times 4 is 64, we say 4 cubed is 64. Then the cube root of 64 is equal to 4. And that's how we say it, the cube root. So we put a little 3 inside the square root sign, so that's not saying square root, it's saying cube root is 64. In other words, what number multiplied times itself 3 times gives me 64? 4 times 4 times 4, 3 fours, is 64. So the cube root of 64 is 4. So a to the n equals b, if and only if the nth root of b is equal to a. So that's kind of what we did here. Since 4 to the third is 64, then you can do the third root of 64 is equal to 4. N is what we call the index. That's the root or the power. We just generally call it the index. So just to review a little bit that you probably remember from Algebra 1, we say that the square root of a number is equal to the positive number. So the square root of 49 is equal to a positive 7. And even though negative 7 times negative 7 gives me a positive 49, positive 7 is what we call the principal square root of 49. Okay? If we want to get a negative 7, then we have to put a negative out front. So negative square root of 49 is negative 7. This means negative 1 times the principal square root of 49, which is going to give me negative 7. That's the opposite of it. And then if we want to deal with both square roots, we do the plus or minus in front. So plus or minus the square root of 49 is equal to a positive or negative 7. So let's take a look at a couple examples here. We need to simplify each one of these. So for number 1, I need the positive or negative square root of 121, x to the 4th, y to the 8th. I'll show you the long way that this works out. So this is equal to plus or minus, and basically we want to factor everything in there. 121 factors to 11 times 11, and then we have 4 x's, and we have 8 y's. Don't worry, this is kind of tedious. I have a shorter way to do it. Let's see, 2, 4, 6, 8. Okay, so because we're taking the square root of this, notice there's no number in here, so there's kind of like an implied 2 in there. This is a square root. I'm looking for buddies. Okay, they're going to buddy up in 2's. And when they do that, they can come out front. So there's an 11. There's an x. And there's another x. And there's a y. A y. A y. And another y. And there's nothing left inside there. Okay? So my final answer is going to be the positive or negative, and because that's out front, it stays out front. 11, since there's 2 x's, x squared, 4 y's, y to the 4th. That's my final answer, simplified. Now, there is a shortcut way to do this. Actually, looking at the number here, you just have to know what the square root of that is, or be able to simplify that. So the square root of 121 is 11, so 11 is going to be out there. Because I'm taking the square root, which is really a 2, I'm really going to just divide whatever my power is here by the index. So x to the 4th, so 4 divided by 2, is going to give me this 2. Y to the 8th, 8 divided by the invisible 2 here, gives me a 4. So that's kind of a shortcut way to do it. What you can do is think of this, x to the 4th is 2 pairs of x's, and y to the 8th is 4 pairs of y's. So that's how you get these exponents in your answers here. Okay? Negative square root of the quantity x squared plus 4x to the 12th power. Okay, I don't want to write x squared plus 4x 12 times and then buddy them up and bring them out. So I'm going to use my shortcut. So it's this whole thing in parentheses here, raised to the 12th power, and I'm taking the square root of it. So I'm going to do 12 divided by 2 to give me 6. So negative times the quantity x squared plus 4x to the 6th power, because 12 divided by 2 here gives me this 6. Don't forget that negative out front. Now, I can kind of do the same thing here, but now notice my index is 3. I'm not doing square roots anymore, I'm doing cube roots. So I'd have to know what the cube root of negative 27 is. What number times itself 3 times gives me 27? And that would be a negative 3. Now I can still do that little division trick. Not x to the 9th, let's take that 9 and divide it by the 3 out here, is going to give me x cubed. Y to the 12th, divide the 12 by 3, that's going to give me a 4. Okay, so why does that work? Well, up here when we were doing the x squareds, we buddied them up by 2's. If I were to write out 9x's and 12y's, which I really don't want to do, I wouldn't buddy them up by 2's, I'd group them by 3's since I'm looking for the cube root. So what this says is I have 3 groups of 3x's, and I have 4 groups of 3y's. So that's how I get this answer here. How about the 4th root of 81x to the 4th? I'll show you in a minute how to do this on your calculator, but if you don't know what the 4th root of 81 is, you can use your calculator to do that. And that's actually 3, because 3 times 3 times 3 times 3 is 81. And I can use my little division trick here. X, the 4th root of x to the 12th, 12 divided by 4, is going to give me an x cubed. And I'm going to do something here that's going to confuse you. I'm going to put absolute value bars around it. And let me explain why. So there's a rule, and I'll write it out for you. It says that if you take the even root, which in this case is 4, of an even power, which in this case is 12, and your answer is an odd power, in this case 3, then you have to use absolute value bars. So let me write that rule out for you. If you take the even root, which remember in this case was 4, of an even power, which in this case was 12, because I was taking the 4th root of x to the 12th, and you get an odd power, in this case 12 divided by 4 was 3, that's my odd power, then you need to use absolute value bars. Okay, so even root of an even power, get an odd, use the bars. Even, odd, bars. Okay, let's take a look at another example here. So now I need the 8th root of x to the 16th power times y to the 8th power. Again, I'm just going to use my division trick. So 16 divided by 8 is 2, so that's going to give me an x squared. Y to the 8th root of y to the 8th is just going to give me a y, but I did the even root of an even power, and I got an odd exponent here, an odd power, so I need to put bars around my y. And that's going to be my final answer. Oh, and I forgot to box this one up here. Okay, so even, odd, use the bars. And the last example here is just to show you how to use your calculator to approximate these. So we're going to use our calculator to approximate each value to 3 decimal places. And notice these are a little gnarly looking. Okay, so let's do the square root of 0.43. So pretty straightforward, square root 0.43. That one's pretty easy. And that gives me approximately 0.656. 0.656. Okay. Now I need the cube root of negative 168. To do this, you're going to go to your math menu here, and notice right here, number 4 is a cube root. So I'm going to use that one, and just put in negative 168. Hit enter, and I get negative 5.518. Negative 5.518. Okay. And my last one is the 6th root of 8,912 squared. Okay, I can do that in my calculator also. So take a look at this math menu. not only do I have a cube root, but here I also have basically an nth root. Notice for number 5 there's a little x, actually it's bigger over here, there's a little x up there. But for my calculator I have to put that number in first. If you hit the button for this, let's see what it looks like here. So when I hit 5, see it puts an X there. If you do that and you get a little box, that's fine. You can go back and put the number that you want your index in that box. I can't do that, so I need to just start over. I need to clear. So I need to put in my root for my index first, which was a 6. Now go to math and let's select that one. So what mine is now saying is I'm looking for the 6th root. And I'm not going to bother to multiply 8,912 times itself. I'm just going to use parentheses and square it. And did I get that set up right? So I want the 6th root of, you know what? Yes, that's right. Yeah, the 8,912 is all underneath the radical sign. And when I hit enter, yeah, I get 20.733. Approximately. Okay, so you can simplify indexes higher than a square root if they're nice numbers like we had back here, and don't forget the trick with the absolute value bars and the little trick with the dividing the exponents, and then for other numbers, and I'll tell you when you need to use your calculator. Just use your calculator to give decimal approximations.